how do you estimate multiple linear regression model? Let us write our generalized multiple linear regression model as yi equals to beta 0 plus beta 1 x 1 I plus beta 2 x 2 I plus beta 3 x 3 I plus beta k x k I plus ui. This is our model. Okay? This is our model. Now, in this model, how do you estimate beta 1 hat, beta 2 hat, beta 3 hat? Now, in the context of two variable, in the context of two variable CLRM, how we got the beta 1 hat? You remember? Beta 1 hat we derived as summation xi minus x bar into yi minus y bar divided by summation xi minus x bar whole square I running from 1 to n, I running from 1 to n. Here I equals to 1 to n. So, I here stands for individual and we have k number of explanatory variable here. So, if we know x and y, we can simply apply this formula to get our beta 1 hat. Now, if we want to estimate so many beta hats, then what we need to do? We need to apply this formula for all these k number of variables, right, which is very time consuming process. You can understand if we have 10 or 15 explanatory variables and you need to compute beta 1 hat, beta 2 hat, beta 3 hat, then you have to apply this formula for so many times to calculate this beta hats, right. So, if we apply the technique what we have learned in our two variable classical linear regression model in this setup to estimate the parameters, then we need to apply the formula so many times. But we do not actually do that in the context of multiple linear regression model. What do we do? We represent this equation using matrix notation, and then from that matrix notation we can easily solve all the parameters at one shot. That is why matrix algebra becomes very important in this context, right. Let us see how do you represent the equation in the matrix notation. So, this equation what I have written yi equals to beta 1 plus x 1 I plus x 2 I plus x 3 I. So, this is for ith individual. Now, we can substitute I for 1, then we will get the equation for the first individual. We can substitute I for 2, then we will get same equation for the second individual. Likewise, we will get the equation for the third individual, fourth individual and then up to nth individual. How does it look like? Let us substitute I for 1, then we will get y1 equals to beta 0 plus beta 1 x 1 1 plus beta 2 x 2 1 plus beta 3 x 3 1 plus beta k x k 1 plus u 1. So, this is for the first individual, first person. Okay. Then I will write the same equation for the second person, and it will look like y2 equals to beta 0 plus beta 1 x1 2 plus beta 2 x2 2 plus beta 3 x3 2 plus beta k x k 2 plus u 2, that is for the second person. Then we will write y3 equals to beta 0 plus beta 1 x13 plus beta 2 x23 plus beta 3 x33 plus beta k xk3 plus u3 for the third person. Likewise, what we will have, we will write the equation for the nth person, y n equals to beta 0 plus beta 1 x1 n plus beta 2 x2 n plus beta 3 x3 n beta k x k n plus u n. Okay, this is how we will write. Now, this is a system of equation. This is a system of equation. This is for the nth person. This is the system of equation. And if we write this system of equation in a more compact way, then what we will write? We can write y1, y2, dot 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 yn equals to what we can write? We can take this intercept beta 0, beta 0, beta 0 outside, then what will happen? This would become 1, 1, 1, 1. Okay. Then we will get x11, x21, x31 dot 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 x k1, then x12, x22, x32 dot 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 x k2. So, then we will get x1n, x2n, x3n, xkn. This is your X matrix, and that should be multiplied with your beta 0, then beta 1, beta 2 dot 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 beta k, okay, plus u1, u2, u3 dot dot un. This is how we can write. Now, we have to think about the dimensions of these matrices. First of all, this y1, y2, yn, what is the dimension of this matrix? Here you see you have n rows but one column. So, this is n cross 1. This is n cross 1. Here you have how many rows? Here also you have n rows, but how many column? K plus 1. So, that means dimension of this is, this would be n cross k plus 1. Okay, n cross k plus 1. What is the dimension of this matrix? Beta 0, beta 1 dot 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 beta k. So, that means you have k plus 1 rows, but only one column. So, k plus 1 into 1. And what is the dimension of this matrix? Here also you have n rows but only one column. So, n cross 1. Now, if you multiply these two, you see n cross k plus 1 and k plus 1 into 1. So, this would become n cross 1, right. So, this entire thing n cross 1, n cross k plus 1 multiplied by k plus 1 into n, when you multiply, the entire thing would become n cross 1. And when you add n cross 1 when another n cross 1 matrix, that would also become n cross 1. Then at the end you will see n cross 1 equals to an n cross 1 matrix. The dimension of the matrices should match, otherwise you cannot go for matrix operation, right, matrix operation. Now, this matrix after this, what we can write actually in more compact form, y equals to then x beta plus u. So, I am writing y equals to x beta plus u, where y is a n cross 1 matrix, this is n cross 1, x is n cross k plus 1 matrix, this entire matrices, that means that all these x and this 1, they constitute, this is the x matrix. You need to clearly understand the structure of this matrix, okay, structure of this matrix. So, this x is basically n cross k plus 1, this matrix, this beta is basically this matrix, which indicates k plus 1 by 1, that means all beta 0, beta 1, beta 2, they are all denoted by, this matrix is denoted by beta, and this u again is n cross 1, this matrix. So, x is n cross k plus 1 and this beta is k plus 1 into this. So, I have written this equation as y equals to x beta plus u. Now, if you compare this with the format what we were discussing, yi equals to beta x plus u, you can observe the difference. Here it is beta x plus u, but when you represent this in a system of equation and then you write this in a matrix notation and then ultimately you express this in a most precise fashion, then you will get y equals to x beta plus u, y equals to x beta plus u, right. This is how you have estimated. Now, what is our objective? Our objective is basically to estimate this, okay, to estimate this. How will you do that? Okay, estimation. I will show you estimation here. Now, in two variable linear regression model, what we were doing? We were minimizing summation ui hat square, we are minimizing this. This is the case for two variable CLRM. Okay. Now, in this context, when you have multiple linear regression model, we should have a similar expression like this. Okay, similar expression like this. Here our u is basically u1, u2, u3 dot 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 un. Now, to get a similar expression like ui hat square, what actually we should do, we should then minimize, instead of summation ui hat square, we should minimize u prime u, u prime u. Okay. This is your u matrix, this is n cross 1. So, you should minimize this. So, that means what you actually minimize, what is u prime u? That means this is a column. So, this would become your u1, u2, u3 dot 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 un, and that you multiply with u2, u3, un. So, this is basically your u prime u, you are minimizing this. Okay. Now, if you multiply this with this, that means u prime u, that means actually you are minimizing u1 square plus u2 square. So, this would become u1 square plus u2 square plus dot 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 un square, and that would become your sum of ui hat square. So, that means this and this now becomes similar. Okay. So, what we minimize here, then basically this is the form we have to keep in mind, that we have to minimize u prime u. And if you minimize u prime u by minimizing u prime u, what we get? We get our desired beta hat is, I am not going to give you the solution, you can try with this, okay? You can try with this. So, after minimizing this at the end, what we will get? We will get x prime x inverse x prime y, where this x is basically the earlier x what we discussed. This x means this is our x, okay? This is our x and this is our y. So, this would become x prime x inverse x prime y, okay? And you know what is the, that means to get beta hat we need to derive the inverse of this matrix, okay? Inverse of this matrix following this x inverse, a simple matrix is x inverse, as you all know, that is adjoint x by determinant x. So, for getting a solution and to get all the beta hats, this inverse should exist. If for any reason this inverse matrix does not exist, for example, if these determinants of x becomes 0 for any reason, then you cannot actually estimate beta hat. You have to keep this thing in mind. This would be useful later on. This should be useful later on when we discuss some important things, right. So, that means from this, if you estimate your beta hat in this way, then at one go what we will get? We will get beta 0 hat, beta 1 hat, beta 2 hat dot 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 beta k hat. So, everything will get at one go. We do not have to apply that summation xi minus x bar yi minus y bar divided by summation xi minus x bar whole square formula k times, right. So, that means in general our approach would be to represent the equation in matrix notation, and then we solve for beta hat following this x prime x inverse x prime y, okay. That is the general notation, and how we are getting it? We are getting it by minimizing u prime u. So, you know the U matrix, you take the transpose and minimize this, and after this you will get x prime x inverse x prime y, where x inverse is as you all know adjoint x by determinant of x. So, that means determinants of this matrix should exist, otherwise you cannot estimate your beta hat. Then you might be thinking, does that mean that whenever we get multiple linear regression model, we need to first represent this in matrix notation and solve this, because as it may look like solving this matrix is also not always easy, because you have so many parameters, then you construct this X matrix, multiply with X, take inverse, then again multiply with X prime, and then multiply with Y. That is also not very easy. You are getting all these parameters at one go, but you have to solve this. Fortunately, we do not have to do anything manually. Fortunately, we do not have to do anything manually, rather our statistical software that we are discussing, that means the statistical software STATA, that will help us estimating everything by a single click. Then why we are discussing all this? To understand what is the theory behind this multiple linear regression model. That means what STATA is actually estimating for us. Unless we understand the theory behind this, what will happen? We won't be able to appreciate what STATA is reporting to us, right? This is how we can estimate. So, once we estimate, lastly what we need to do? We need to interpret yi equals to alpha plus beta 1 x1 I plus beta 2 x2 I plus beta k x k I plus u I. So, when I am writing this model, this is for k variable model, how do you interpret beta 1 hat? How do you interpret this? Earlier we learned the interpretation of this model, yi equals to alpha plus beta 1 x1 I plus ui. If you do not have any other variable, then in this context how do you interpret? For a unit change in x1 I, for a unit change in x1 I, yi changes by beta 1 hat amount on an average. But here, how do you interpret beta 1? You have so many other factors. That means, to understand the interpretation of beta 1 hat, what I will tell you, you first take the expectation of this. So, if you take expectation, your expectation of, so what I will do, I will show you the interpretation here. So, first what you do, if you take expectation of yi, then what will happen? Expectation of yi given xi, that would become alpha plus beta 1 x1 I plus beta 2 x2 I plus beta k x k I, okay, after expectation. Now, if you differentiate this equation, if you differentiate this expectation of yi given xi partially with respect to, this is the partially with respect to x1 I, what you will get? This is expectation of yi given xi delta x1 I, that is nothing but your beta 1 hat. Now, you can easily interpret this. That means, if you know the interpretation of partial differentiation from mathematics, you can easily get the interpretation of beta 1 hat. This basically says that for a unit change in x1 I, yi changes by beta 1 hat amount on an average, keeping the impact of other factors constant. That means, the earlier interpretation is true, but additionally we have to add that keeping the impact of other factors constant. Since this is a multiple linear regression model, if you cannot keep the impact of other factors constant, then actually this beta 1 hat, what you will get, you are going to claim that this is actually impact of education, let us say, on your wage, but actually this is not the net impact. This would become a combined impact of other factors as well when you have multiple variables in your model. So, that is why the explanation would become for a unit change in x1i, yi changes by beta 1 hat amount on an average, keeping the impact of other factors constant. So, keeping the impact of other factors constant, this is the additional thing we need to add in the context of multiple linear regression model to get beta 1 impact estimate interpretation of beta 1 hat. So, that means beta 1 hat we can say alternatively in this context is net impact of x1i on yi. When you have two variable linear regression model, the concept net impact does not arise because you have only one variable. Whatever impact x1i will give you on yi, that you are getting directly by beta 1 hat. But here we need to keep the impact of other factors constant. Okay? We need to keep the impact of other factors constant, otherwise we will not be able to get the net impact of x1i on yi. Now, the question that comes to our mind is very challenging. Okay? In the context of multiple linear regression model, now we are facing a challenging question. What is that question? When I am giving you data, let us say I am giving you data on x1i, x2i, x3i and your yi, and I am asking you, you estimate your beta 1 hat, you tell me what is the net impact of x1i on yi. That means how do you keep the impact of other factors constant empirically? That is a very challenging question, isn't it? Keeping the impact, interpretation looks very simple. Interpretation looks very simple, that keeping the impact of other factors constant, what is the net impact of x1i on yi, that is given by beta 1 hat. But when you are working with empirical data, the question then is, how do we keep the impact of other factors constant in an empirical setup while dealing with data on x1i, x2i, x3i, x3i xki and yi. Okay. So, even though the interpretation looks very simple theoretically, empirically it is very challenging, because unless you keep the impact of other factors constant, it is really difficult to get the net impact of this. So, what we will learn in our next class with a data set, then we will learn how to actually keep the impact of other factor constant empirically. That is going to be very, very interesting, but that we will discuss in our next class. Thank you.